Hello again, everyone, and welcome to my next crash course video. Today we're going to talk about using prime factorization to find the greatest common factor. Let's do a little bit of reviewing first. Let's remind ourselves, what is a factor? So a factor is a number we use in multiplication. We multiply two factors together to find our product. When we want to find the factors of a specific number, we want to find all the numbers we can multiply together to equal our number as a product. So again, we have a factor multiplied by a factor, and that's going to equal our product. So when we're finding factors of numbers, we're finding all the numbers that multiply together to equal that specific number. Let's talk about now what a prime number is. A prime number is a number who's only evenly divided by 1 or itself. So what we mean by that is that there's only one way to equal that in multiplication, and it's by multiplying itself by 1. Some examples of this would be the number 2. The only way to multiply to equal that would be 2 times 1. 3, 5, 7, 11, 13, 17, 19, 23, 31, 37. These are all examples of numbers that we can only multiply to equal by multiplying itself by 1. So that is what a prime number is. So let's talk about now, what is prime factorization? So we see that the word prime, we see the word factor. So what we're doing is we're creating factor trees to break down our specific number that we've been given. We want to continue breaking down that number until we come to the prime numbers that make up that actual number. So when we identify all the prime numbers that make up our number, we can multiply them together in the end. If you did it correctly, it should equal what your original number was. So let's look at a number as an example here, like 96. So I'm going to go ahead and branch off, hence the term that we use at a factor tree. So I know one way to multiply to equal 96 is 8 times 12. Now when we create these branches, we're separating them off so that we know that these are the numbers that we multiply together to equal what our given number was. Now, 8 can break down into multiple different forms, and 12 can break down into multiple different forms. So let's break down the number 8 first. I know that 4 times 2 equals 8. I can't break down 2 anymore because there's no other way to multiply to equal 2 other than multiplying it by 1. I can, however, break down 4, and I can break that down into 2 times 2. Let's take a look at how we can break down 12 now. I know that 2 times 6 equals 12. Again, I can't break down 2 anymore because only 2 times 1 equals 2. But I can break down 6, and that equals 2 times 3. The prime numbers that make up 96 are 2, 2, 2, 2, 2, and 3. So I have 2 times 2 times 2 times 2 times 2 times 3. If we did this correctly, these numbers should multiply to equal 96. So I have 2 times 2, which equals 4. 4 times 2 equals 8. 8 times 2 equals 16. 16 times 2 equals 32. And then finally, 32 times 3 equals 96. I've identified all of the prime numbers that make up 96 when we multiply them. Let's take a look at another example. Let's take a look at 42. I know one way to multiply to equal 42 is 6 times 7. Now again, remember that these are numbers that we can multiply together to equal our original number. I can't break down 7 anymore, so I'm going to break down the 6, and I know that 3 times 2 is going to equal 6. Now my prime numbers here are 2, 3, and 7. So 2 times 3 times 7. So 2 times 3 equals 6, and as we already saw, 6 times 7 equals 42. Now, let's take a look at how we can use that method of prime factorization to find the greatest common factor of two or more numbers. So, what you're going to end up doing is you're going to make factor trees for both of the numbers that you are given, or for all of the numbers you're given. You're going to find sets of prime numbers that they have in common. So what I mean by that is if they have multiple of one specific prime number in common, you count each one of a set as a set, and we count them as sets of two. So we're finding pairs of the same number that equal one set. When you find all the prime factors that they have in common, you're going to multiply them together to discover the greatest common factor. So let's take a peek at an example to see how this actually works with two numbers. So I'm going to take the number 28 and I'm going to take the number 36. I'm going to find the ways first that I can multiply to equal these two numbers. So one way I know how to multiply to equal 28 is 7 times 4. Now I know I can't break down 7 anymore because 7 is a prime number, but I can break down 4, which equals 2 times 2. Let's take a peek at how we can break down 36 and get down to those prime numbers. I know one way to multiply to equal 36 is 6 times 6. I could break down both of these 6's, obviously, as in 3 times 2, and then, of course, 3 times 2. Now, we're going to find the sets that they have in common now. So, they have a set of 2. They have another set of 2. And that's what they have in common. So now, to find the greatest common factor, I'm going to multiply these numbers that they have in common together, which equals 4. So the greatest common factor of 28 and 36 equals 4. Let's look at another example using some larger numbers here. So I have 84 and I have 45. Now let's find ways that we can multiply to equal both of these numbers. One way that I know that I can multiply to equal 84 is 7 times 12. Of course, I can't break down 7 anymore because that's a prime number, but I can break down 12 as in 6 times 2. I can't break down 2 anymore because that is a prime number, but I can break down 6 in the form of 3 times 2. Let's see how we can break down 45 now. I know that 5 times 9 equals 45. I can't break down 5 anymore because 5 is a prime number, but I can break down 9, which equals 3 times 3. In this case, they only have one set in common, which is a set of 3's. So, the greatest common factor of 84 and 45 equals 3. Let's take a look at one more example here. I've got the number 72 and the number 24. And let's find ways that we can multiply to equal these numbers. So I know one way to equal 72 would be 9 times 8. I can break down both of these numbers. Neither one of these numbers is a prime number. In fact, we call them composite numbers because there's multiple ways to build up to equal them. So let's break down 9 first. I know the way that I can multiply to equal 9 is 3 times 3. The way I can multiply to equal 8 would be 2 times 4. I can't break down 2 anymore, but I can break down the 4, which equals 2 times 2. Let's take a peek at how we can break down 24 now. I know one way to multiply to equal 24 is 6 times 4. I can break down both of these numbers still. And one way to break down 6 would be 3 times 2. And the way I break down 4, of course, is 2 times 2. Let's see all of the sets that they have in common. So I know that I have a set of 3. I have a set of 2. I have another set of 2. And I have another set of 2. Now, I can multiply these numbers together to discover what the greatest common factor of 72 and 24 is. So 3 times 2 equals 6. 6 times 2 equals 12. And 12 times 2 equals 24. So the greatest common factor of 72 and 24 is 24. I want to thank you guys very much for watching this latest crash course video. I hope that it was helpful for you in finding another way to find the greatest common factor between two or more numbers. Feel free to check out some of my other crash course videos that I have on here anytime. And as always, happy mathing.